Okay, we are being asked to find the average value of a function on some interval. And so while you don't really have to understand completely what it's asking in order to be able to get the answer or understand what the answer means, I want to talk just a little bit about that so you can think a little bit about whether your answer makes sense or not. So when we're talking about anything about a function on an interval, these are values for the input variable x. So this is from x equals 1 to x equals 3. So they say it in this way on an interval, but that's what that actually means. When I think about average value of a function, I tend to think about that geometrically and graphically. So I might think about the graph of this function. This is not a function that you probably just off the top of your head know what the graph looks like. So you get out your graphing utility, Desmos, or your graphing calculator, and graph that. And you're especially interested in the part of the graph from x equals 1 to x equals 3. So I'm going to just sketch this. I used a graphing utility to help me think about this. This function's undefined at x equals 0, so I wouldn't expect to see any points at x equals 0, but that's not in our interval here. I'm really interested in the interval from 1 to 3. And so when I look at the graph of that function, I see something that looks sort of like this on that part of the graph. And I might pay attention to coordinates of points at x equals 1 and x equals 3. So I could use my graphing utility to help me figure those out, or I could also plug in x equals 1 to the function and evaluate it myself and figure out what that y coordinate is. So when x equals 1, I get y equals 4. 1 comma 4. And when I put in x equals 3, my graph is not to scale here, but when I put in x equals 3, I get 9.5 repeating, or 9 5/9. I'll just put 9.5 repeating. And of course, you can use a decimal approximation. You don't really need any of this, actually. But just thinking about what it's asking me to find. So if I think about the area under this curve, from x equals 1 to x equals 3. We know how to do that. It's an integral, definite integral. But what average value is asking you to find is to imagine that you have this region that has 3 straight sides. So you're going to have an x-axis. That's always going to be your x interval here. And then 2 vertical lines at those x values. So one side, so straight lines everywhere. And then the 4th side of your region is curvy, maybe. Could be a straight line, but it's curvy. And so what this is really asking you to find is thinking about if you just flattened this out and made it a flat top region with the same amount of area in that, where would that flat top be? And so you can sort of see it's going to have to be somewhere here between 4 and 9.5 repeating. So if I had a graph with a scale on it, that might be more helpful here. But if you just sort of think about if I flatten that off and squish this down and raise that up so that it's flat, but still have the same area, what it's asking me to find is what is this height? Or what is the value of that function at that point? That's what it's really asking you to find. And so again, you can look up the formula for how to find average value of a function on an interval and do the calculations for that and get an answer, the right answer, without really thinking about any of this, but it can be helpful to think about whether your answer is reasonable or not. I should expect my answer to be somewhere between 4 and 9.5 repeating, maybe a little closer to 4. If you look at the graph carefully, you can, on a graphing calculator or something, you can kind of see the shape of it. And when I drew this, I didn't quite draw as steep as that is, but probably a little closer to 4 than 9.5 repeating. Okay, so when I look up the formula, though, for average value of a function, you can remember the formula from thinking through the geometry, but most students really just look up the formula or memorize the formula. So I'm going to write that formula down here, and then we'll use it on this function. So average value of a function f on an interval a to b is equal to 1 over b minus a, so subtracting your endpoints of your interval, and then integrate from a to b of your function. So this is a definite integral of your function. All right, so I'm just going to use that formula with this function on this interval. So we will have 1 over 3 minus 1 or you could just write 1 over 2 here. And then you're going to integrate from 1 to 3. And you're going to integrate your function. Okay, and then you're just going to do this definite integral. So we're going to use fundamental theorem of calculus to evaluate this integral, find our antiderivatives, and plug in our endpoints and subtract. When students do these problems, a lot of times they forget this little coefficient out front, this 1 over b minus a. So sometimes I see students who try to do the integral first and then think they're going to remember to do the 1 over b minus a out front later. I tend to forget it, and I see a lot of students forget it if they don't write it down to start with. So my advice is to write that down to start with and then carry it forward in your work so that it doesn't get lost in your steps here. So I'll just have a 1/2 out front. And then I need to think through these antiderivatives. So what I want to think about is, first of all, this is a sum of functions. So I can separate an integral term by term as long as I have a sum of functions. I'm really thinking about this like 3 separate antiderivative problems. This one is one I know, power rule. This one is one I know, it's the logarithm function, ln of absolute value of x. This one is distractingly like 1 over x. So sometimes people try to use a natural log for that. But we've talked about, kind of since we started this unit, if you have 1 over or 2 over or whatever over something else that's not just x, it's not just that ln, something else. And so the first thing I would think about here is, well, what would I do if I were going to take a derivative of this instead of an antiderivative? And what I would do is rewrite that as a power. So you could write it as a whole other step, but I'm going to just cross this out and write above that 2x to the negative 2 is how I want to think about this term and find the antiderivative of that. Okay, so I'm going to go ahead and write down antiderivatives of all of these. Put some brackets here. So I'm not going to write my integral sign anymore because I'm doing what it told me to do. So I'm not going to keep writing that. Antiderivative of x squared would be 1/3 x cubed. This one. All right, and then this next term here, so the 2 can come along out front, coefficient can come along out front, and then antiderivative of x to the negative 2, so I can just use my same power rule that I used on this first term. So we'll add 1 to the exponent, so we'll have x to the negative 1, and then out front of that will be 1 over negative 1. Okay, so these are my 3 antiderivatives. And then I'm going to have that evaluated from 1 to 3. All right, so we've been using these definite integrals for a couple days now, just thinking through what that is asking us to find, right? So and how we write that. We did the antiderivatives. I now need to evaluate from 1 to 3. All right, and so I have a choice here about what I'm going to do with the 1/2. I can just have it pulled out front of everything and then remember to distribute it through. I'm going to choose to kind of treat it as part of this whole thing evaluated at x equals 3 and then minus this whole thing evaluated at x equals 1. All right, so I'll have 1/2 times 1/3 times 3 cubed plus ln of absolute value of 3. Might tidy up that coefficient a little bit there. So 2 times 1 over negative 1 is negative 2. Just rewrite that above there. So negative 2, and then I'll have my x to the negative 1, so 3 to the negative 1, which is the same thing as 1 over 3. So I might write that term as negative 2 over 3. So negative 2 times 3 to the negative 1. 3 to the negative 1 is why that's on the denominator. Okay, so I have this whole function evaluated at 3, and then minus this whole thing evaluated when x is equal to 1. And then here I'll have minus 2 times 1 to the negative 1, or minus 2 times 1 over 1, or that just becomes minus 2 over 1, or just minus 2. Okay, so at this point I have my answer. It's in kind of an ugly form, and maybe you want to simplify that or maybe not. On the WebAssign homework, you can just type in a messy answer like this. Sometimes it will ask for a decimal approximation, so you can do a decimal approximation of this. Just type this whole thing into your calculator. That would be okay. I'm going to go ahead and do a little simplifying. You don't have to do that, but there are a few things that I could simplify here. So first of all, 1/3 times 3 cubed. So 3 cubed is 27. 1/3 times 27 is 9. So this whole term just becomes 9. This whole term, 1 cubed is 1 times 1/3. So this whole term just becomes 1/3. Natural log of 1 is 0. And this whole last term here just becomes 2 over 1. So maybe we clean that up a little bit more. I would have 1/2 times 9, that's 9/2. Then plus 1/2 ln of 3. I can also remove these absolute value bars because absolute value of 3 is just 3. And then 1/2 times negative 2/3. The 2's will cancel. I'll have minus 1/3. Here I'll have negative 1/2 times 1/3 minus 1/6. This part's 0. This last term here is 2. So negative 1/2 times negative 2 will be plus 1. You could type your answer like that. You could go ahead and add the fractions here and the numbers all up and do that. You could go ahead and do that if you want. There's a property of logarithms you can use if you want. So if you have kind of online homework that's going to show you an answer after you get it wrong enough times, they might do all of those things. I honestly don't care if you take the time to do all of those things. I'm fine if you leave your answer like it was the previous step I had the box around, or like this, or if you want to go ahead and simplify that, you can. If you need a decimal approximation, you can do that really at any point here. So we put that into your calculator, and I think for this one we get about 5.2. That's helpful for making sense of my answer here, that this height here should be somewhere between 4 and 9.5 repeating. So if you get that decimal approximation, that's helpful sometimes if you think about the geometry. Okay, we'll look at an application problem in the next video for finding average value for some sort of word problem.